For 3a, we're going to use synthetic. No, we're going to use long division. It says that on your paper, right? Long division to determine the dilation constant and whether or not there is a reflection. Then we're going to graph it. All right? So let's go 3a and let's bring it in. X plus 1 over x minus 4. If you're going to do this with long division, what goes here versus here? What goes in the inside box? The numerator. Outside box, denominator. If you don't set that up right, there's no way you'll get it right. Okay? So the bottom goes outside, the top goes inside. Ready? Here we go. You need to think, what number would go here? It's not a 0, that's just a circle. What number times x makes x? 1. Now distribute it. What's 1 times x? X. 1 times negative 4. Put a line under it and subtract the quantity. All right? What's x minus x? 0. What's 1 minus negative 4? That's our remainder. Here's what you do with it. You take the 1 and you add the remainder over the divisor. So that tells me that this hyperbola is shifted right how many? Up and dilated by. So here we go. You're going to put a vertical asymptote right 4. So go right 4 on your graph and draw a dotted line coming straight down. That's your vertical asymptote. All right? This one on the outside tells me that it's shifted up how many? 1. Put a horizontal asymptote at 1. If this 5 was a 1, that's an if. If this 5 was a 1, I would just go from these crossroads, right? From the new location of the meeting point of the asymptotes, I would go 1, 1. And then I'd make a hyperbola. And then I'd do it here, 1, 1. And then I'd make a hyperbola. We talked about this last week, though. If this was a 2, it would dilate. 1, 2, 2, 1. Then you'd make your hyperbola. If it was a 9, give me some combinations that make 9. 1 times 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 3. And 9 times 1 would be way over here, right? And then it would get dilated out like that. Well, it's not a 9 or a 2 or whatever. It's a 5. So from here, you're going to go, from here, you're going to go 1, 5. Up 1, right 5. And then make a curve that looks like that. All right? Do the same thing in this lower left of this crossroads, of these crossroads right there. So you're going to go 1, 5, 5, 1, and make your curve look like that. One last thing. If that remainder would have happened to be negative, this numerator would have been negative, these two arms would have been reflected this way and that way. All right? That's if that remainder would have been negative. Just in case you see that on the quiz.